Today we are going to learn about mastering experiment tracking with weights and biases. In this video, we will cover how to set up, manage, and interpret your machine learning experiment data for improved reproducibility and collaboration.
Welcome to our session on mastering experiment tracking with weights and biases. In today's fast-paced world of machine learning, keeping track of your experiments is crucial for replicability, transparency, and collaboration. Weights and biases is a powerful tool designed to help data scientists and researchers efficiently manage their experiments. It's a platform that offers features like metric logging, visualization tools, and collaboration dashboards, making it easier to maintain the integrity and reproducibility of your projects. In this video, we'll guide you through the essentials of using weights and biases to improve your workflow and results. To start using weights and biases, you first need to create an account on their platform. Once registered, the next step is to install the WAND Python library, which is the core utility for interacting with weights and biases from your code. You can easily install it using pip. After installation, configure your environment by logging in through the command line. This process will require an API key that you can find in your weights and biases account settings. With your environment set up and connected, you're ready to initialize your first project. This involves defining the parameters of your experiment, such as the machine learning model you're using, dataset details, and any specific metrics you wish to track. Proper setup is fundamental as it lays the groundwork for efficient experiment tracking. Logging metrics is a core feature of weights and biases that allows you to track the performance and behavior of your machine learning models over time. By logging metrics, you can visualize data in real-time dashboards, making it easier to spot trends, anomalies, and areas for improvement. The platform offers customizable visualization options, enabling you to tailor your dashboards to focus on the most relevant metrics for your project. This could include accuracy, loss, precision, recall, and other important indicators. Understanding how to interpret these visualizations is crucial for making informed decisions about model adjustments and optimizations. Moreover, the ability to customize visual outputs means you can communicate your findings more effectively to collaborators and stakeholders.
Managing multiple versions of your experiments is an essential skill in data science, and weights and biases makes this process seamless. With it, you can track changes across different iterations of your experiments. This includes modifications to parameters, datasets, and code. The platform provides intuitive tools for version control, allowing you to compare different versions side by side. By doing so, you can easily identify which changes led to improvements or regressions in your model's performance. Additionally, having a comprehensive experiment history allows you to efficiently manage iterations, reduce redundancy, and focus on the most promising approaches. This systematic management of experiment versions is fundamental for continuous learning and development in your projects. Collaboration is a significant advantage of using weights and biases. The platform enables you to create shareable dashboards that facilitate seamless communication and insight sharing among team members. These dashboards can be customized and shared with your team, providing a comprehensive view of your experiments and their outcomes. The collaborative features offered by weights and biases include real-time updates and notifications, allowing team members to stay informed about the latest developments. By streamlining workflows through integrated collaboration tools, you enhance your team's efficiency, reduce miscommunication, and foster an environment of continuous improvement. This collaborative approach is integral to successful data science projects, where teamwork and shared insights drive innovation and success.
Automation is a powerful way to enhance efficiency in experiment tracking, and Python scripts offer a flexible means to achieve this with weights and biases. By integrating automation scripts, you can reduce the manual workload associated with tracking and logging experiments. Python's versatility makes it an ideal choice for writing scripts that automate various aspects of your workflow, such as initializing experiments, logging metrics, and managing versions. The WAND library provides API hooks that easily integrate with Python scripts, allowing you to automate repetitive tasks and focus on more critical analyses. Embracing automation not only saves time but also ensures consistency and accuracy in your experiment tracking efforts, ultimately leading to more reliable and reproducible outcomes.
Interpreting experiment results is a critical skill in machine learning, enabling you to draw meaningful insights and make informed decisions. Weights and biases provides robust tools for analyzing visual data, helping you identify patterns, trends, and anomalies in your metrics. By evaluating these visualizations, you can gauge the effectiveness of your models and pinpoint areas for improvement. This process involves understanding the relationships between different metrics and their impact on overall model performance. Armed with these insights, you can make data-driven decisions to refine your models and enhance their accuracy, efficiency, and reliability. Effective interpretation of results is key to continuous model improvement and achieving better project outcomes. Reproducibility is a cornerstone of scientific research, and this holds true in machine learning experiments as well. Adopting best practices for reproducibility ensures that your experiments can be reliably replicated and validated by others. This begins with meticulous documentation of your experiment setup, including parameters, datasets, and code versions. Standardizing your experiment processes helps maintain consistency and reduces the likelihood of errors. Utilizing version control through weights and biases allows you to track changes and maintain a clear history of your experiments. By adhering to these practices, you enhance the integrity of your research and contribute to the collective knowledge in the field of data science. Consistent and reproducible experiment tracking is essential for building trust and credibility in your findings. Weights and biases offers a range of advanced features that can further enhance your experiment tracking experience. One such feature is hyperparameter tuning, which allows you to optimize your models by systematically adjusting parameters. The platform also provides model comparison tools, enabling you to evaluate multiple models and select the best performing one. Advanced visualization options offer deeper insights into your data, with the ability to create custom plots and graphs. Additionally, you can track custom metrics specific to your project needs. Weights and biases' robust API integrations allow you to connect with other tools and platforms, streamlining your workflow and expanding your capabilities. Leveraging these advanced features can significantly elevate your experiment tracking and model development processes.
To illustrate the impact of effective experiment tracking, let's explore a real-world case study. In this example, a data science team faced challenges in managing complex machine learning experiments with multiple versions and parameters. By implementing weights and biases, they were able to streamline their tracking processes, resulting in improved efficiency and collaboration. The team could log and visualize critical metrics in real time, allowing them to quickly identify and address issues. As a result, model performance improved significantly, leading to better project outcomes. The lessons learned from this experience highlighted the importance of proper setup, documentation, and collaboration in achieving success. The team plans to further enhance their tracking capabilities by exploring additional features of weights and biases and integrating more automation into their processes. As we conclude this session on mastering experiment tracking with weights and biases, let's recap the key topics we've covered. We explored the setup and configuration of your tracking environment, the importance of logging and visualizing metrics, managing multiple experiment versions, and collaborating effectively with your team. We also discussed the benefits of automation, interpreting results, and best practices for reproducibility. By leveraging the powerful features of weights and biases, you can significantly enhance your machine learning workflows, leading to more accurate, efficient, and collaborative outcomes. We encourage you to apply the skills learned today in your projects and continue exploring the capabilities of weights and biases for even greater success. Thank you for joining us, and happy experimenting.